Hello, my name's Daniel Leonard,
And I'm Sam Mortensen.
and this is our project for Small Worlds Component 2.
Our component one summary. Our research topic was SAT scores versus family income in America. Our question was, how does a person's family income affect their SAT score in America? We chose this question from many other topics that you can see below, such as SAT scores versus income, college costs versus income, do the college GPA versus income, bachelor's degree or higher degree versus income, scholarships and type of scholarship versus taxes, high school GPA versus income, and how a gap year affects a person's eventual income.
So, for our rationale, we said that this research topic can show how important it is to go to college. One of the main reasons that people go to college is to prepare themselves for a higher paying job and to be able to make more money. If people on average are making less money not having a bachelor's degree, college can be seen as more worth it. But if people on average without a bachelor's degree are making the same amount of money as people with one, then it appears less useful to have a college degree.
College is one of the most expensive things we'll ever pay for. According to Value Penguin, an organization that specializes in research on insurance policies and other expensive financial programs, the average cost of college for the 2017 to 2018 school year was $20,770 for public schools that are in the state that a student already lives in, and $46,950 per year for nonprofit private schools, and that is only including tuition, fees, and room and board.
SAT scores are a great tool for measurement because they have a large range. The lowest possible score is 400 and the highest is 1600. Because of this, the scores can be very precise. They are easy to measure. Higher SAT scores make it easier to get into colleges, and comparing students from lower income families to higher income families can help show the inequalities in the education system.
We then looked into 4 different websites that showed and explained data and the meaning behind it. They gave us the values and the relationships between SAT scores and family incomes, and that gave us a better understanding of the topic we were researching. The websites we looked at were Value Penguin, the Bureau of Labor Statistics, College Find, and the United States Census.
So after compiling all of this information and data from the websites, we created some tables and graphs to compare the data and display the data from the years 1985, 2000, and 2015.
How we found the equations. We used both endpoints of the graph, where one had 0 as the x value, and then plugged the x and y values into the exponential equation. F of x equals a times b to the x. Since one of the points had x equals 0 for all 3 graphs, we could calculate the value of a, and using the other endpoints and the newfound value of a, we could calculate the value of b and figure out the exponential equations, meaning of the graphs and equations. Looking at the equations in chronological order, we see that the value of b decreases. This means that a few decades ago, people whose families made less than $50,000 a year would have a lower SAT score, whereas now families with $50,000 per year are scoring slightly higher. In addition to this, we saw the graphs had a very similar exponential curve, but looking at the tables, the values were off by a few numbers. For example, the families with an average income of $100,000 a year scored an 1195 in 1985, but students coming from families with the same income scored about an average of 1205 in 2015.
So moving on to the AROC problems with analysis and descriptions. First, AROC, or average rate of change, is just the average rate of change between 2 points on an exponential graph. And the way we calculated it for our 3 problems was by plugging the numbers into the equation f of the first value of x minus f of the second value of x over the first value of x minus the second value of x, and that gave us the average rate of change. So After doing our calculations based off of the 2000 graph, we found that the average rate of change was larger in the beginning of the graph and smaller at the end of the graph. And this is important to know because this proves that the difference in SAT scores are smaller when the family income is larger, meaning that the already wealthy families have more of a head start against students whose families make less.
IROC problems with analysis and descriptions. All of these problems are based on the 2015 graph. IROC, or the instantaneous rate of change, is the average rate of change at a specific point on the graph. We took measurements of IROC at different points on the graph to see how the incline of the graph changes from each point on the graph. We found a similar pattern for the IROC on this graph and the AROC from the 2000 graph. From the data we collected, we discovered that since the IROC was higher at the beginning of the graph and lower at the end, the average SAT scores for families with higher incomes are closer to the scores of families with lower incomes. This is because this is important because it shows how a larger divide is being formed between the scores of families with their income and families with lower incomes.
And our future predictions for 20, 50, and 100 years from now. So we reached our calculations by looking at the SAT scores and their corresponding incomes from the 1985, 2000, and 2015 graphs, and tried to calculate how much the SAT score was increasing over those 15-year spans. And we estimated that it was about, the SAT scores went up about 10 points every 15 years. So with this information in mind, we needed to set up ratios to see how many times 15 years fit into 20 years, 50 years, and 100 years. So after getting these numbers, we multiplied them by 10 to figure out how many points the SAT scores would go up 20, 50, and 100 years from now. And we know that these predictions are accurate because the graphs follow the same exponential curve and increase in similar fashions to the 1985, 2000, and 2015 graphs. So this is important because it can tell us how much harder and competitive it will be to get higher paying jobs. According to these predictions, in as little as 50 years, the average person whose parents make $100K a year will score a 1238 on the SAT, which is 63 points higher than in 1985.
Doubling and tripling. Every year the SAT score goes up about half a point for each year that passes. We are seeing how much time it takes for the score to double. 0.5 times 2 is 1. So the amount of time it takes in years is the score itself. And you can see those actual values below. Tripling. Similarly to the doubling calculation, the average point per year is still 0.5. This time 0.5 times 3 is 1.5. This means that at 1.5 times the original score is how long it will take to triple. You can see these values below. These scores cannot actually be reached because the SAT has a cap on 1600.
So in conclusion, the simplest way to put our finding is that the more money someone has, the higher that they score in the SAT. The average score of people who make $25K a year has gone up 15 points over the last 30 years. The same thing happens across the board. $1 million a year also increases 15 points. The curve is starting to straighten though. This is not a good thing. While more money is starting to mean an even larger advantage, over time this disparity will only increase.
People with higher paying jobs tend to be coming from the same schools who are demanding higher scores and more money. If something doesn't change, the wealth divide in our country will only continue to grow larger.
All right, there's our citations, and thank you for listening. Bye.
Thank you for watching.